Namaste students, welcome back to my channel. Students, today in this video we'll learn about the sulfur dioxide. We'll talk all about the sulfur dioxide, whether the preparation, whether the properties, whether the uses. So all things of sulfur dioxide we'll cover in this video. So without any delay, let's get started. First, we'll talk about the preparation of sulfur dioxide. That is, what are the different methods through which we can prepare sulfur dioxide. So, we have a number of methods through which we can prepare sulfur dioxide. The very first method is the burning of the sulfur in the presence of the air. So, very first method is the burning of sulfur in the presence of air. So whenever we burn sulfur in the presence of air, then we get sulfur dioxide, but along with the sulfur dioxide, we also get sulfur trioxide. So the amount of sulfur trioxide is very less, that is nearly 6 to 8%, but yes, we get sulfur trioxide also. So whenever we burn sulfur in the presence of air, then we get sulfur dioxide, and along with the sulfur dioxide we get little bit amount of sulfur trioxide also, that is 6 to 8%. Now second method is the laboratory method. Now in laboratory we can prepare sulfur dioxide by treating the sulfides with the dilute H2SO4. How? By treating, first method is by treating sulfides with dilute H2SO4. For example, Fe2SO3. This is iron sulfide. So when FeSO3 reacts with H2SO4, and this H2SO4 is dilute one. So when Fe2SO3 reacts with H2SO4, then we get Fe2SO4 plus SO2 plus H2O. So in laboratory, we can prepare sulfur dioxide by treating the sulfides with the dilute sulfuric acid, and we have one more laboratory method, and that is by heating copper turnings with concentrated H2SO4. So this is also the laboratory method. If there is a question that in laboratory how we can prepare this sulfur dioxide, so you can answer any of the two methods, because both the methods are the laboratory method. So by heating copper turnings with the concentrated sulfuric acid, and the reaction becomes Cu plus H2SO4. But here the H2SO4 we have to take, that is the concentrated one. In this the dilute one is sufficient. So here when copper reacts with concentrated H2SO4, we get CuSO4 plus CuSO4 plus SO2. We get CuSO4 plus SO2 plus H2O. So these two are the laboratory method through which we can prepare the sulfur dioxide. Now third one is the industrial method. In industry, we can prepare sulfur dioxide as a byproduct during the roasting of the sulfide ores. So we can prepare sulfur dioxide as a byproduct during the roasting of the sulfide ores. I hope you all know what is roasting. Roasting is the burning of the sulfide ore in the presence of the air to convert the sulfide ore into the oxide ore so that it can be easily reduced. That is known as roasting. So for example, I have a sulfide ore, let it be ZNS, that is zinc blende. So when I heat zinc blende in the presence of air, then I get zinc oxide plus sulfur dioxide as a byproduct. So in industry, we can prepare sulfur dioxide as a byproduct by the roasting of the sulfide ores. So these are the methods through which we can prepare sulfur dioxide. Now, if we talk about the structures of the sulfur dioxide, in our previous video, we have studied in detail the structure of sulfur dioxide. So if you have not seen that video, I'll provide you the link of that particular video. So I'm skipping the structure of the sulfur dioxide in this video because it was already told in the previous video. Now, next we will talk about the properties of the sulfur dioxide. Next we will talk about the properties of sulfur dioxide. We will take the physical and the chemical properties together. So next we will take the properties of sulfur dioxide. Properties of sulfur dioxide. First property is it is a colorless gas. It is a colorless gas with a pungent smell. With a pungent smell. This is the first property of the sulfur dioxide, that it is a colorless gas with a pungent smell. Second, it is highly soluble in water. Second, it is highly soluble in water. Highly soluble in water. Third property is it is acidic in nature. Now, how we get to know that it is acidic in nature? When SO2 dissolved in water, then it forms H2SO3, that is sulfurous acid. And because of the formation of the sulfurous acid, we get to know that sulfur dioxide is acidic in nature. And in our previous videos of oxide, if you remember that I told you that the oxides of the non-metals are acidic in nature, and sulfur is a non-metal and its oxide is sulfur dioxide, so it is also acidic in nature. So when sulfur dioxide reacts with water, it forms sulfurous acid, and therefore it is acidic in nature. And because of this, it is also known as anhydride of sulfurous acid. It is also known as anhydride of sulfurous acid, because when it reacts with water, then it forms sulfurous acid. Means we can prepare sulfur dioxide from the sulfurous acid by dehydration. That's why sulfur dioxide is known as anhydride of sulfurous acid. Being acidic in nature, this SO2 reacts with the base to form the salt and water. For example, this SO2 reacts with NaOH to form Na2SO3 plus H2O. So being acidic in nature, it reacts with the base to form salt and water. And when this Na2SO3 reacts with excess of sulfur dioxide, then it forms NaHSO3, that is sodium bisulfite. This is sodium sulfite and this is sodium bisulfite, ITE. So when SO2 reacts with NaOH, being acidic in nature, it forms salt and water. And when it reacts with excess of SO2, then it forms NaHCO3. Being acidic in nature, it also reacts with the carbonates, metal carbonates, to liberate carbon dioxide. For example, Na2CO3. This sulfur dioxide reacts with Na2CO3 to form NaHSO3 plus CO2. So being acidic in nature, this sulfur dioxide reacts with the metal carbonates to liberate carbon dioxide gas. There is an interesting fact about sulfur dioxide, that just like that of the carbon dioxide, it also reacts with the lime water in the same manner. In our junior classes, we have studied that how carbon dioxide reacts with the lime water. That when lime water reacts with carbon dioxide, then due to the formation of calcium carbonate, there is a milkiness in the water, and when it reacts with excess of carbon dioxide, the milkiness disappears. Similar reaction we will study in sulfur dioxide. So sulfur dioxide also also reacts similarly as reacted by the carbon dioxide with the lime water. The reaction is same. So when we write the reaction with the lime water, the reaction is CaOH whole twice plus SO2. This CaOH whole twice reacts with SO2 to form CaSO3. Because in that case we get CaCO3. That is calcium carbonate. So in this we get CaSO3 plus H2O. And when this CaSO3 reacts with SO2 again, reacts with excess of SO2, then we get CaHSO3 whole twice, and due to the formation of this CaCO3, the lime water becomes milky. And due to the formation of this soluble part, the milkiness disappears. So the reaction is same as performed by CO2, as shown by CO2. So this is the similarity between the carbon dioxide and the sulfur dioxide. So when sulfur dioxide reacts with lime water, then it forms calcium sulfide, and when calcium sulfide reacts with the excess of sulfur dioxide, then it forms calcium bisulfide. Now the fourth property, that is combustibility. The fourth property is the combustibility. Now sulfur dioxide is neither combustible nor a supporter of combustion. Clear? There is a statement for sulfur dioxide that sulfur dioxide is neither combustible nor a supporter of combustion. But some of the elements like heated carbon, heated magnesium, heated potassium, they keep on burning in the presence of sulfur dioxide. Now the question is how? Question is clear to you or not? That sulfur dioxide is neither a combustible nor a supporter of combustion. But still, some of the elements like heated carbon, heated magnesium, heated potassium, they keep on burning in the presence of sulfur dioxide. Now, what is the reason behind this? The reaction of heated carbon with sulfur dioxide, the reaction of heated magnesium with sulfur dioxide, and the reaction of heated potassium with sulfur dioxide produce a very high amount of energy. That high energy reaction results in the breakage of the sulfur dioxide into S and O2. Means the high energy of these reactions converts sulfur dioxide into sulfur and O2, and the O2 which is formed in the reaction, that is a supporter of combustion. That's why these metal keeps on burning in the presence of sulfur dioxide. So whenever the reaction occur at a high energy, that reaction results in the decomposition of sulfur dioxide into sulfur and oxygen, and this oxygen help in the combustion. Therefore, we write the reaction C plus SO2. That is not simple carbon, that is heated carbon. Heated carbon plus SO2 gives CO2 plus S. Similarly, heated magnesium reacts with SO2 to form MgO plus S, and similar reaction occur with the potassium. So, first thing, sulfur dioxide is neither combustible nor a supporter of combustion. It is a true fact. But why these metals keeps on burning in the presence of the sulfur dioxide? Because very high energy reaction. These are very high energy reaction, and that energy results in the decomposition of the sulfur dioxide into sulfur and dioxygen, and this dioxygen help in the process of the combustion. That's why these metal keeps on burning. So these are the four properties of sulfur dioxide. Now we will take the fifth property, that is the important one property, that is the reducing property of the sulfur dioxide. Now sulfur dioxide behave as a good reducing agent in the presence of moisture. in the presence of moisture, sulfur dioxide behaves as a good reducing agent. Why? So fifth property is reducing property. So when the moisture is there around the sulfur dioxide, it reacts with the moisture to form H2SO4 and nascent hydrogen. So due to the formation of this nascent hydrogen, this sulfur dioxide behave as a good reducing agent in the presence of the moisture. Now we will write some reactions in which we will see the reducing property of the sulfur dioxide. The very first reaction we will write, like Cl2 reacts with SO2 in the presence of moisture. SO2 convert this Cl2 into HCl and itself get converted into H2SO4. So in this way, SO2 results in the reduction of the sulfur, a reduction of the chlorine. Chlorine get converted into HCl. Similarly, if we have iodine, we can convert iodine into Hi. If we have bromine, we can convert bromine into HBr. Now the second reaction is KMnO4. KMnO4 is pink in color. Now when it reacts with sulfur dioxide in the presence of moisture, then we get K2SO4 plus MnSO4 plus H2SO4, and this MnSO4 is colorless. So this SO2 converts the pink color of the KMnO4 into the colorless MnSO4. In this way, it results in the reduction of the KMnO4. Now, if I write the third reaction, that is K2Cr2O7, which is orange in color. This reacts with sulfur dioxide in the presence of moisture. Then we get K2SO4 plus Cr2SO4 whole thrice plus H2SO4, and this one is green in color. So in these two reactions, due to the change in the color, we get to know that the chemical reaction is taking place, because in this the pink color get converted into colorless, in this the orange color get converted into green color. Now if I write the fourth reaction, that is Fe2SO4 whole thrice, this reacts with SO2 in the presence of moisture, then we get Fe2SO4 plus H2SO4. FeSO4 plus H2SO4. So here the oxidation state of iron is +3, but here the oxidation state of iron is +2. So +3 to +2 means there is a reduction. So this SO2 acts as a reducing agent. Now if I write the next reaction, KiO3 reacts with SO2 in the presence of moisture, then we get KHSO3 plus I2 plus H2SO4 So through these reactions, we get to know that the sulfur dioxide behave as a reducing agent in the presence of moisture. So in the presence of moisture, sulfur dioxide act as a good reducing agent, because in the presence of moisture it release nascent hydrogen which help in the reduction. Now because of the release of this nascent hydrogen, it show another property, that is the bleaching property. So the sixth property is bleaching action. So due to the formation of the nascent hydrogen in the presence of the moisture, this sulfur dioxide has a bleaching action, and it it convert the vegetable colorful material matter into the vegetable colorless matter, means the delicate items like wool, silk. So it is used for bleaching the delicate materials like silk and wool, So because of this nascent hydrogen, it converts the vegetable colorful material, means vegetable coloring matter reacts with nascent hydrogen and converted into colorless matter. This is the bleaching property of the SO2. But there is an important fact about the bleaching property of SO2, that this bleaching property of SO2 is temporary. This is not permanent. As soon as we expose the matter in the air, this matter regain its color due to oxidation. So this matter regain its color due to oxidation. When we expose this matter into air. So the bleaching property of sulfur dioxide is temporary, and when we expose that particular matter in air, then the color of that particular matter is regained due to the oxidation. Now, in this we have studied that it is act as a reducing agent, but sulfur dioxide also acts as an oxidizing agent. But there is a condition, that it reacts with a very strong reducing agent, means a reducing agent which is more powerful than sulfur dioxide. Whenever sulfur dioxide reacts with an agent which is more powerful reducing agent than the sulfur dioxide, then sulfur dioxide behave as an oxidizing agent. So the next property of sulfur dioxide is oxidizing property. Next property is oxidizing property. And when it behave as an oxidizing agent, when it is reacting with a reducing agent which is more powerful than the sulfur dioxide. So the next property is oxidizing property. So the condition for showing the oxidizing property, I hope clear to you, that when it reacts with more powerful reducing agent, then it behave like an oxidizing agent. For example, when it reacts with H2S, which is more powerful reducing agent than SO2, so the reaction becomes H2O and S. Now this SO2 acts as an oxidizing agent. Similarly, when it reacts with carbon dioxide, then it forms carbon monoxide, then it forms carbon dioxide plus sulfur. When it reacts with SnCl2 in the presence of HCl, then it forms SnCN4 plus H2O plus S. In this also, it is getting reduced, means it act as an oxidizing agent. Similarly, Hg2Cl2 when reacts with SO2 in the presence of HCl, then it forms HgCl2 plus H2O plus S. So through these four reactions, we get to know that sulfur dioxide also behave as an oxidizing agent. But when it behave as an oxidizing agent, when it is combined with another reactant who is more powerful than it, then only it acts as an oxidizing agent. Otherwise, it acts as a reducing agent in the presence of moisture. Now, the next property are other reactions. Now, the addition reactions. Now we will see the addition reactions. Now, when this SO2 reacts with O2 in the presence of vanadium pentoxide at 773 Kelvin, then it forms SO3. When this sulfur dioxide reacts with oxygen in the presence of vanadium pentoxide as a catalyst at 773 Kelvin, then it forms sulfur trioxide. So this is a kind of addition reaction, because in this two reactant combines to form a single product. Similarly, when this SO2 reacts with Cl2 in the presence of charcoal, then it forms SO2Cl2, that is sulfuryl chloride. When this SO2 reacts with Cl2, in the presence of charcoal, then it forms SO2Cl2, that is known as sulfuryl chloride. So these are the addition reactions in which two reactant combines to form a single product. Now, through sulfur dioxide, we can prepare thionyl chloride also, which is an important reagent. So we can prepare thionyl chloride from the sulfur dioxide. So the next property is reaction with PCl5. So when this sulfur dioxide reacts with PCl5, then it forms SOCl2 plus POCl3. And this SOCl2 is known as thionyl chloride. So with the help of sulfur dioxide, we can prepare sulfuryl chloride as well as we can prepare thionyl chloride, which are important reactant in the organic chemistry for the preparation of a number of compounds. So these are all about the properties of the sulfur dioxide. Now we'll study the uses of sulfur dioxide. So the very first use of sulfur dioxide, it is used in the manufacture of a number of compounds. Like sulfuric acid, sodium hydrogen sulfide, etc. So this sulfur dioxide is used in the manufacture of a number of compounds like sulfuric acid. So without sulfur dioxide, we can't prepare sulfuric acid. In the preparation of the sodium hydrogen sulfide and in many other compounds. So first of all, it is used in the manufacture of a number of compounds. Second, it is used as a preservative. Preservative for jam, jellies and squashes. So it is used as a preservative. Means if we kept jam, jellies and squashes in sulfur dioxide gas, then they remain fresh for many days. So it is used as a preservative for jam, jellies and squashes. Next, liquid SO2 is used as a refrigerant. So liquid sulfur dioxide is used as a refrigerant. Now the fourth point is it is used as a disinfectant. To kill germs, microbes and fungus. So it is used as a disinfectant to kill germs, microbes and fungus. Next, it is used as an anti-colorant to remove excess of chlorine from the bleached articles. If excess of chlorine is present in the bleached article, then with the help of the sulfur dioxide, we can remove chlorine from the bleached article, and that's why sulfur dioxide is known as anti-colorant. And how it remove chlorine? Because it reacts with the chlorine to form the sulfuryl chloride. So excess of chlorine is removed by the sulfur dioxide from the bleached article, therefore it is known as anti-chlorant. Therefore, it is used as anti-chlorant. So these are the different uses of the sulfur dioxide. So students, in this video, we have studied about the preparation of sulfur dioxide, different properties of sulfur dioxide, and uses of sulfur dioxide. And I told you, if you want to study the structure of the sulfur dioxide, I'll provide you the link in the description box, so that you can go through that link and you get to know that how means in which manner the sulfur dioxide is arranged in three-dimensional space. So that's all for today. I'll see you in my next video with a new topic of the oxygen family.